My name is Alejandro Ojeda, and today I'm going to talk about my lab for oscillation. So first, let's get some key concepts. The first is the energy principle formula, which is the change of energy, which is equal to the delta kinetic, which is the change of kinetic energy, plus the change of potential energy. There's two potential energies. That is a spring potential energy, which is equal to 1/2 times the spring constant times the displacement of the spring squared, which just means the final length, the magnitude of the final length of the spring minus the initial length of the spring. And then gravitational potential energy is the mass times gravity times displacement. So, and for on the other hand, will be kinetic energy, which is 1/2 times mass times velocity squared. In addition, we need to know that the system is the Earth, the spring, and the mass, and there are no surrounding forces. That means then we also know that another way to get delta E, which is the change of energy, will be the work plus the heat, which is just force times delta R or delta distance. Now, since there are no surroundings, work is zero. Therefore, delta E or change of energy is equal to zero. That means that force of gravity is equal to the negative force of the spring. So then, net force is equal to zero when because the sum of force of gravity plus the force of the spring will equal zero. Now in this code is to examine the motion of the spring system in which the mass swings in an arc while oscillating on the spring and compare results of the Python tracker. But beware, I had some technical issues. So in the tracker analysis, as shown in this video, I had 15 frames per second. The weight of the mass was around 0.2 kilograms. The spring constant was around 10.9 newtons per meter. The initial length was around 0.19 meters. The observation time around 4.6 seconds. And the initial position was 0.531 meters in the x-axis and negative 0.346 in the y-axis. Sorry about that. Okay, so here is the first line of code. It just shows you what I did. Just basically plug in the formula for the energies on line 93 to 96 and put the initial position that we found in ball position. Here's more coding. Basically, just trying to find out the length of the spring and etc. And unfortunately, my video did not work well, and I was not able to compare the tracker and the glow script, unfortunately. So although I don't have a video showing you the graphs, I can still say that the position in both graphs will be similar, but not the same, especially the y-axis, because there are more forces in the y-axis than in the x-axis. And now this is due to possible errors, such as the possible need to be more accurate with initial conditions that I use, more such as like the initial spring length. And in addition, rotational energy was not accounted for, and that could have affected the results. So I can answer at least one of the questions, which is the energy principle satisfied? Yes, it is satisfied because there are no external forces, meaning that all energies added up will equal zero. Unfortunately, I can't answer the other question because my graph didn't work. Still, thank you so much.